Welcome to today's video lecture session on registers and RAM memory allocation in 8051 microcontroller. Myself, Manus Kumar Parai. So this is the objective of delivering the lecture. It is basically the prerequisite for writing the assembly level language programming. So a brief overview of the registers inside the 8051 microcontroller will be described. After that, the memory space allocation for both the memory like the ROM and ROM will be described over here. So this is the 8051 CPU registers. As we are familiar with the registers, in case of any kind of the microprocessor or the microcontroller, most commonly used the register is the accumulator. So here is the accumulator, is also one 8-bit byte accumulator, and other one is the B register. The B register is common for the microprocessor 8085 and the 8051. But here in case of 8051, the B register is somehow it will be different from the B register which is used in 8051 microprocessor, because especially it is used in 8051 microcontroller to divide to 8-bit numbers or to multiply to 8-bit numbers directly. So which provision is not given in case of 8085 microprocessor. The register PSW means the program status word. It is nothing but the flag register in case of the 8085 microprocessor. So next is the stack pointer. The stack pointer is 8-bit byte in case of 8051, but in case of the microprocessor 8085, the stack pointer is of 16-bit byte. So the registers are common, but the main difference is that the 8051 most commonly used the registers are of 8-bit byte, except the program counter and the DPTR. The program counter is common for the microprocessor 8085 and for 8051. But here the DPTR is the newer one. The data pointer is the most, it is commonly used by 8051, but it is very important register inside the 8051 CPU. It can be divided into two. One is the data pointer high and data pointer low. So 8-bit wide the data pointer register can be accessed, or it can be clubbed together to access one 16-bit register as your data pointer register. Okay, so all of just residing inside the CPU. So what is this program counter? So we know that the program counter is pointing the address of the next instruction that is to be executed, and the CPU fetches the output from the program ROM. Actually, we are the programmer. We are writing the program inside the ROM. So program counter is increasing to point to the next instruction. We are writing the program inside the ROM. So whatever the kind of the ROM we are using, either the double-letter ROM or EEPROM or EEPROM or the flash type of the ROM. But actually we are writing the program to one inside the ROM, so that the program will be permanently stored for the definite period of time until and unless I am erasing it and I am just burning within the program. So the program counter is of 16-bit byte, so it can access the memory address from 0002 FFFF next. So total 64 kilobytes of the external ROM I can connect with the microcontroller 8051. And all 8051 members starts with the memory address 000, because whenever I'm switching on my device, my reset value of the program counter is equal to 0000. So always it is expected that the first instruction should be written inside the ROM, which is starting from 0000. So 00, because the 8051 looks for the first instruction when it is booted. This is the ROM memory mapping technique. So now the member of the 8051 family can access more than 64 bytes of the opcode of the memory space. But here in case of 8051, only 4 kilobyte of the ROM is given to the user, means it is given by the manufacturer. So the space from 000 to 0FFF means this 4 kilobyte of the ROM space is used by the user. And the IC 8051 or the 8810C51, then the ROM space is limited. But actually, with this program counter, 16-bit program counter, I can access the memory which is starting from 0002 FFFF, that is 64 kilobyte. So the other variation of the other manufacturers like Dallas Semiconductor, they are producing the ROM memory starting from 0002 3FFF. The another variation is that 00002 7FFF. It is also coming from the manufacturer Dallas Semiconductor. So there are so many variations are there. So accordingly, you can choose as per your requirement. But most of the students from the BTech or the MTech, if you are doing the project or the prototype, if you are designing the prototype, I think 4 kilobyte the memory space is sufficient to implement your project or your prototype. Okay. So this is the RAM allocation in 8051. So 128 bytes of the RAM space is given by the manufacturer, which is embedded inside the 8051 microcontroller chip. So it is mainly starting from the address, because it is 128 byte of the RAM. So the starting address will be 00 and ending address will be 7F. It is represented in hex. So it is divided into 3 different groups. So we are dividing the overall memory location, overall RAM location, starting from 00 to 7F into 3 different sections. One is, you see that 00 to 07, then 08 to 0F, 10 to 17, then 18 to 1F. It is under this one, means the 32 bytes of the location from 00 to 1F. Okay, we are just giving the name of this particular section as your register bank. Okay, so register bank, you can find that register bank and stack. Okay, so register bank and stack. So that concept will be discussed in a short period of time. So don't confuse with that concept that the register sets like A, B, PSW, data pointer, program counter, all are the register from the CPU. But this register is actually which is lying inside the 8051 RAM. Okay. So the next part means 20, the location from 20 to 2F, it is bit addressable RAM. Means these 16 byte of the location starting from 20 to 2F, they are set aside for the bit addressable read-write memory. Okay, so that is the most important feature of 8051. They are bit addressable. Okay, so each and every location, each and every bit from every location can be accessible to the user. Means you can use the overall 8-bit at a time by putting the address at 20, or 20 is again divided into different 8 cells. From each and every bit you can access. Okay, so it is known as your bit addressable RAM. After that, 30 to 7F, these 80 bytes of the memory location are the scratchpad RAM memory location. Okay, the scratchpad memory location means you can compare it to your copy. Means you are just using the pen, or you are using the pencil and your paper. Okay, so you can write something and then you erase it. Okay, so it is just like your notepad or the scratchpad. That is the memory location inside the RAM memory location starting from 30 to 7F. Okay, so 32 plus 16 plus 80, there is total 128 bytes of the RAM, and they are allocated. Means the memory space is allocated in this way. Okay, so this is the bank. Means if we zoom this portion, what is written that if we zoom this one, means 00 to 1F. If this location is reserved for the register banks, and we are just trying to zoom it, so we are finding the bank 0, means here the registers which are designated as your R0, R1, R2, R3, R4, R5, R6, and R7. So 00 to 07 means these 8 different registers are occupying this space, this lower portion of this memory location. Okay, the RAM memory location means 00, then 01, 02, 03. So this address is reserved for the register R0, R1, R2, R3, R4 from bank 0. This is from bank 1. This is 08 to 0F. It is reserved for bank 1. It is reserved for bank 2, bank 3. So the 4 register banks are there, and each and every bank is having these registers. The name of the registers are same, means the designation of the registers are same like your R0 to R7. They are also residing in this location, which is inside the RAM memory location. Okay, so in bank 1 the name is same, bank 2 name is same, the bank 3 all the register name they are same. And how to access it? How to access the different registers from different bank, because they are addressed different. You will find that the address is 00 for R0 and 07 for R7. If we write the same name over here, the address will be different. Okay, so how to access it, that will be discussed. So you can see that the general purpose registers, these are the general purpose registers. They are occupying the lower portion of the RAM memory space. Then the bit addressable, and there the location from 30 to 7F, there are this scratch pad. Means it is available to the user. You can write some data, you can erase it. And the upper end 128 byte, that is mainly the special function registers, because the address 00 to 7F, that is available inside the RAM. Okay, you can access the RAM with this address 00 to 7F, but with this 21 means I can access 80 to FF. Means with these 2 bytes, then I can access up to FF. Means from 80 to FF, these are actually the special function registers. Okay, so what is the special function register, that will be discussed later. You see that what is the what is the register sets are available in the different banks. So we have to segregate the register set along with that bank, means along with their different banks location. Okay, so it is the main of the important register that is used by 8051 microcontroller. Okay, so what is the comparison between that? What is that in the program status word? That is actually we know the flag registers in 8085. So the common name is also used here for 8051, but it is specially the name is given for 8051, that is program status word. But it is basically the flag registers. So what the flag registers in the right hand side, it is given over here, because if I provide it in that slide, then it will be easy to understand, easy to compare with the flag bits that is available for 8085 and the flag bits available for 8051. So in case of the microprocessor, out of the 8-bit different locations from D0 to D7, though it is 8-bit registered, but actually 5 different flags are there. Take carry flag, parity, auxiliary carry flag, the 0 flag, the shine flag. So these are the flag registers, or these are the flag bits inside the flag register of 8085 microprocessor. But here you'll see that few flag bits are common as we have used in case of 8085, like your carry bit, the carry flag, the auxiliary carry, the parity. Okay, the F0 is only these 3 one, like the carry, the auxiliary carry, and the parity. These 3 bits are common as we have used for 8085 microprocessor. Okay, the newer thing is that F0. So F0 flag is available to the user for general purpose. It is RS1 and RS0, that is register bank selector bit 1 and register bank selector bit 0. Okay, and OV means actually overflow flag, and this is user definable flag, it is not governed. So the parity flag is there. So according to that, either it will be 0 or 1. Accordingly, you can indicate which the number is either the even number or the odd number. And see that the one beauty of that 8051 microcontroller is that the program status word is also bit addressable. Okay, bit addressable means in the individual bit is accessible to the user. Means I can assign a particular 8-bit number for a program status word, or directly I can access a particular bit. I can set this one, I can decide this one. Okay, so PSW 0.7 means it is actually indicating the carry flag. Okay, PSW 0.6 it is indicating the auxiliary carry. PSW 0.5 it is indicating the flag 0. PSW 0.4 it is indicating RS1, means register bank select 1 and register bank select bit 0, which is the 3rd bit, means actually it is the 4th bit from the program status word. This is RS0. Then overflow flag. So all the flag bits are designated by their particular flag bit locations. Okay, so accordingly, so how to choose this bank from there? Means first of all, you have to select the particular bank by choosing the particular bit from the program status word. This RS0 and RS1, these 2 bits are responsible for selecting the particular register bank. Okay, so how to select it? As I have already discussed that, I have already told that the program status word is bit addressable, means you can access the bit RS1 and RS0 separately. Okay, so I can set the bit, I can reset the bit. So with these 2 bits, how many combinations are possible? 4 combinations are possible. It may be 00, it may be 01, it may be 10, or it may be 11. Okay, So array 1 and array 0, if it is 0, 0, register bank 0 will be selected. Okay. Register bank 0 will be selected. Okay. So address range will be 00 hex to 07 hex. Means R0, then R1, R2, R3, R4, and R6 and R7 registers will be selected, which are coming from register bank 1, bank 0. Then if I place the RS1 is equal to 0 and RS0 is equal to 1, then I shall select in this way I can select the register bank 1. So address will be selected here 08, 09 and up to 0F. So it is the registers R0 to R7, but they are coming from bank 2, bank 1. Okay. Similarly, for RS1 equal to 1 and RS0 equal to 0 means the register bank 2 will be selected. So the address 10 to 17 will be assigned. Okay. So the registers are same, but we are selecting the particular bank, the particular register from a particular bank by providing a particular input in the RS1 and RS0. Okay. If both the inputs are equal to 1, 1, then register bank that will be selected by the microcontroller, that is equal to 3. Okay, so address will be 182, 1F. So in this way, I can segregate the bank. My registers are same, but which register I am selecting from which bank, that will depend on that particular bit position, the status of the bit in the RS1 and RS0. Okay, that is program status word 0.4 and program status one 0.3. Okay, so register bank 0 is the default bank because whenever we are powering up the 8051 bit, then the reset value is 0, 0. So register bank 0 is by default, it will be selected. So to select the other banks, means if I am not specifying that which bank which register is coming from this which bank, so by default the register R0 to R7 will be selected, those who are coming from register bank 0. Okay, so let us take this one. So by default the registers will be R0 to R7, that will be selected from bank 0. So that is the default bank. Okay, now to choose bank 1 or bank 2 or bank 3, I have to write the program. Okay, so I have to write this one. I have to write the program in this way, means I have to set the particular bit, I have to reset the particular bit. So this is the program I have considered intentionally I have considered over here, but that program will be the assembly language programming technique will be discussed in the third lesson. But here you see that move R0, that is the immediate data which is indicated, preceded by one hash symbol, means hash signifies that it is the value, means 99 is the value. All the instruction will be MOV, like your the microprocessor 8051, there was one instruction MVI, but there is no MVI instruction in case of 8051. All the instruction will be MOV. Okay, so it will load the value 99, means the data is tagged with the instruction itself. Therefore, 99 will be loaded in the register R0. So that you have to specify that is the data, because now the data is tagged with the instruction and it will be preceded by one hash symbol. It signifies that it is a value. Okay, then I am just moving the data, or I am copying the data 85 hex in R1. Then you can write here also in this way, like move 00, because 00 is the address of R0. So any register can be can be chosen by using their proper name, or you can choose their address also. In which way you will find that it is convenient, and you can choose it. You can choose it whenever you are just writing the assembly level language programming. Okay, so R0 you can write it because it will, most of the user they will prefer to write the name of the register because it is convenient to write the program. So you can write it in this way also, move 00. Similarly, move 01. So 0001 here, these registers are actually coming from bank 0, because by default the register bank 0 will be selected and the register R0 and R1 were coming from bank 0. Then to choose the other banks, like I have to choose the bank 2, wherefrom I have to choose the register R0 R1. So how to write this one? Then I shall write this instruction set B PSW 0.4 because it is RS1. So to select bank 2, I have to set the RS1, means PSW 0.4, and I have to reset RS0, then it is 0, means RS0 will be equal to 0. So set B PSW.4, it will create a 1 for RS1 and clear PSW.3 means it will create a 0 for the RS0 bit. Okay, so therefore now if I put the register R0 after executing these two instructions, then R0 whatever it is considered over here, now it will be coming from bank 2. Okay, these registers will be coming from bank 2. Similarly from for R1, it is also the register which is coming from bank 2. Okay, bank 2, this one. The name is same, but we are choosing the bank 2 by selecting the proper bit in the program status word. Okay, so set B PSW.4. So the second line, you see that the clear PSW.3, it may be included or it may be excluded, because by default the register means the RS1 and RS0 value will be 0, 0. Means program status word, all the bits will be 0 whenever I am just switching on my device. Therefore, initially that bit will be 0. Only which one is to set, then I have to write the particular instruction for that. Set B PSW.4, even that I am writing that one. The third one, then I'm writing the fourth one. That is also valid because already it is clear whenever I'm just switching on my device. Okay, so this instruction is redundant. You can avoid this one or you can include this one as you can prefer it. Okay, so this is the overall picture of inside the 8051 RAM memory locations. So find that the default register banks are R0 to R7, as we have already discussed, then bank 1, bank 2, bank 3. So all are just different in their address. After that, the bit addressable memory locations are starting from 20 memory location. So 20, then 21, 22, 23. So we can access this overall 8-bit location by providing the address to 0. So every bit will be considered. So it will be treated as your 8-bit instruction or 8-bit data, and that will be considered. Otherwise, a particular bit you can consider from here. Okay. So 20, then here it is 21, like a 22. So 0, 0 means 20 is the memory location, and the bit address is 0, 0, and 01, then 02, 03, 04, 05, 06, and 07. After that, it is coming 08, means it is from the address. The next 8-bit address starting from 08, 09, 08. So if I write in the instructions means 00, and you may confused with that 00 because this 00 is means the instruction itself specifies that whether it is the address or it is the bit address. Okay, because whenever I'm writing set B means I'm setting the bit, means I am setting 1 as your bit. Set B means PSW.4 is equal to 1. That will be 1 if I write set B. Set the bit PSW.4. Clear the bit PSW.4. So obviously this instruction is indicating a particular bit location. It is not accessing the 8-bit at a time. Okay. So set B clear, it is already indicating a particular bit. So this bit is accessible to the user and individually you can access it. Whenever I'm writing with this instruction like set B 00, so obviously that 00 will be treated as your particular bit position from the address to 0. Okay, so that 00 and that 00 will not be coincided or will not be confused with that concept, because whenever I'm writing the move 00 means actually we are copying the data 8-bit data from this address 00. So at 00 is the address which is holding the data 8-bit data inside register R0. Now 00 means set B 00 means it will indicate a particular bit location. Whenever I will writing say 09, actually it is indicating this particular bit location from the memory location address location to 1. Okay, so bit set B 0B means if I am writing on a program where my instruction is set B 0B, it will automatically indicating this particular bit because the instruction itself specifies whether it is the address for a 8-bit location or it is the address for a particular bit location. Okay, therefore it is bit addressable location. The bit addressable location can be accessed by the user. Individual bit can be accessible, or you can directly use 8-bit at the same time. Okay, after that this scratchpad memory location is starting which is known as your general purpose RAM. As we are using pencil and the paper, we can scratch it, means we can write everything, every rough work can be done over there, then I can erase it because it is written with the pencil, not we are writing with pen. So using pencil and paper, we can use this scratch pad. So it is the most important part of the RAM location, which is freely accessible to the user. Okay, so this 30279, what is important as far as the stack location is concerned, or the stack concept is concerned. Okay, so before that we shall discuss about the stack, because one question might be appearing that why we're writing stack in register bank 1. The stack, the concept of the stack will be discussed elaborately in next lesson. Therefore, in lesson 3, a little bit concept will be delivered now to understand the stack management in 8051. When it is powered up, the default value of the stack pointer is 07. Okay, so the default value is 07. So during the execution of any relevant program where the stack is used, means where the relevant program means where the stack is used, the stack pointer will be incremented by 1. Okay, the stack pointer will be incremented by 1. So it is a common conflict of this stack concept between many microprocessor and the microcontroller. In case of 8085 microprocessor, after the execution of the relevant instruction, the stack will be decremented by 1. But human being, we are the human being, are habituated with the conventional method of incrementing or decrementing the number. Okay, let us take an analogy of bookkeeping system inside the library. Okay, a series of the books are placed one by one inside the book cell. So one book is added anytime the number of the books presently available inside this stack, it is incremented by 1. Okay, or it will be incremented by 1. So if a book is issued from there, the counting of the books will be now decremented by 1. So the stack concept of the 8051 microcontroller is very similar with this concept adapted inside the library. Okay, so the place inside the book cell is nothing but the stack. Okay, so where the stack is placed means where the book is placed one by one, then you can find that what is the particular book is present inside this cell. Then actually where it is located means actually we are indicating the particular address of a particular book which is present inside the book cell. So place in the book cell is nothing but the stack, and the unique call number means you know that accession number and the call number, and the unique call number which is indicating the address of the particular book means actually the where the book is located inside the library's book cell. Okay, so the address, the call number inside the book is nothing but the address which is analogous to the address of the memory location. Actually, it is the stack pointer for this stack. Okay, so most of the programmers are getting confused with this concept of stack and the stack pointer. Now I think you will be able to differentiate between them. Okay, so let us come to the topic again. So after the execution of the instruction, this stack pointer value will be incremented by 1. That is, the value will be equal to 08 in case of 8051. But you can check from the RAM allocation table that 08, that is the 08 is the register address from bank 2. Okay, bank 1. So the stack and bank 1 has coincided. Okay, so before switching on the device, you can find the reset value of the stack pointer is 07. So whenever I'm just switching on my device, then the stack pointer value is 08 because it is incremented by 1. So the critical, it is just like a critical situation which is appearing now. Okay, so this critical situation is not actually the critical situation for the programmer, because handling of that situation is not a big deal for the programmer. What a programmer will do is that he or she will initialize the stack pointer at the beginning of the program with the address of the location, that is from the RAM memory location, from say 30 location, and which is approaching towards the 7F address. Okay, now the scratchpad memory locations will be assigned as your new stack locations. Okay, Thus, you can avoid the conflict between the register bank 1 and the stack. The lesson 3, we shall discuss about we shall consider one good example to clarify it again. Okay. So actually, this stack concept is somehow it will be different from the concept of 8085. So stack is the portion of the RAM memory location. So I have to manage it. I have to manage the stack location. I have to initialize my program in such a way that this stack will be initialized with the value with the address which is starting from my stack pointer will be loaded with the value starting from say 30, which is approximately to 7. Okay. Therefore, this scratch memory location, if I use this memory location, then it will not be coincided with the register bank, because in a program I can use the register bank 1 also. Okay. So in this way, I can avoid the conflict between bank 1 and bank and the stack. And that the video is very helpful. Then you kindly share, like my channel to get the notification of the next lessons. Thank you everyone. Thank you for watching my video.